Welcome to today's video, presented by yours truly, Aiden, Zabi, and Hassan.
In this video, we will explore the idea of Gauss's law, specifically its application on an infinite plane of uniform charge. I will also introduce the idea of area charge density, which will be integral to having a plane of uniform charge. Gauss's law is the idea that the electric flux of any charge can be determined by placing it within a closed surface, such that all field lines run through the enclosed surface. Typically, the surface enclosing the charge or charges is a sphere and uses the equation phi equals q over epsilon naught, where flux is represented with phi, q is the charge enclosed within the Gaussian surface, and epsilon naught is the electric constant. For area, we then use the formula phi equals E times A times cos theta, where phi equals the electric flux through the Gaussian surface. E equals the uniform electric field, A equals the area perpendicular to the electric field lines, and theta equals the perpendicular angle between the electric field and normal of the area. Charge density works on the principle that like charges repel, such that they have equal distance between them, making them at the furthest point away from another charge as possible. Let's start with electric charges, specifically point charges. Point charges can either be positive or negative. If we have 2 point charges, they can exert forces on each other. Now, whether this force is attractive or repulsive depends upon the sign of these 2 charges. If they're opposite charges, they attract each other. If they're the same charge, they repel. This is due to the fundamental consequence that all things want to be in equilibrium, but that's not entirely in the scope of this video. But we must keep in mind that all charges have electric fields, and with electric fields there are electric field lines. For a positive charge, its electric field lines go outwards, whilst in a negative charge the lines go inwards. Now, let's move on to the main topic. Gaussian surfaces. These are surfaces in which the total flux or flow of electric field lines going through some area can be calculated. Typically, this is shown using a hollow sphere, much like a balloon. This allows the charge to be calculated because all electric field lines are enclosed within the sphere, as opposed to an open surface which would let some field lines escape.
Now let's use Gauss's law to find electric field strength. To apply Gauss's law, we use a pillbox, a cylinder with faces parallel to the plane, because it matches the symmetry. The curved side do not contribute in the flux because the field runs parallel there. Only the top and the bottom matters. Now let's get started. Gauss's law states that the flux is equals to the enclosed charge over epsilon naught. Thus we get phi equals q over epsilon naught. The total flux passing through each surface is Ea cos theta. Since the angle between the electric field and the area is 90 degrees, then the total flux is E times A. Since we have 2 faces, it can become 2 times E times A. Thus, phi can also be written as 2 times E times A. The enclosed charge Q is the charge density sigma times the area A. The area cancels out and we get an equation for electric field. This tells us that electric field created by a uniformly charged infinite plane is uniform and independent of the distance, which is very different from how fields behave around point charges. The field strength depends directly on the sigma, double the charge density, double the field. But unlike a point charge, distance does not weaken the field thanks to the infinite plane's symmetry.
To summarize, electric charges create electric fields, and these fields are visualized through electric field lines. Electric flux tells us how much of electric field is passing through a surface. Gauss's law connects these flux to the amount of enclosed charge. And finally, we apply Gauss's law to a uniformly charged infinite plane. We find a unique result, a constant electric field that does not decrease with distance. Thank you for watching. Have a good day. Please like and subscribe.